Hi everyone, I am Mrs. Fitzpatrick, and today we're going to be doing lesson 6.5, which is about solving polynomial equations. And in this lesson, we're really just going to solve them by factoring. So we are going to go ahead and just start with we're going to do all the odd problems together. Once I do those, go ahead and work on the even ones on your own. So here are just some general guidelines for solving polynomial equations. So step one, you always want to start by moving all terms to one side of the equation. Make sure it's set equal to 0 first. Then factor the polynomial completely. Finally, we use our zero product property, and you can set each factor equal to 0 and solve for each x value. Now, you can use all of the methods if it's a quadratic that we learned in the last unit. So for quadratic equations, you could solve with square roots, completing the square, or quadratic formula. You may even be left with a quadratic that you can't factor when you are solving these polynomial equations. And we'll get into some examples like that. All right, let's take a look at number 1. So we have x cubed plus x is equal to 0. Let's go ahead, and it's already set equal to 0, so let's go ahead and start by factoring. Well, I'm noticing that there is a greatest common factor between x cubed and x. They share a common factor of x, so let's go ahead and factor an x out. Then I'm left with x squared plus 1 is equal to 0. Well, from there, I can't really factor much more, but I can set each factor equal to 0 and solve. So I'm going to go ahead and set x equal to 0. I'm also going to set x squared plus 1 equal to 0 and solve. Now from here, looking at that x squared plus 1 equals 0, I would say we should definitely use the square root method. So let's get x squared by itself. Subtract 1. X squared equals -1. Our next step is I'm going to go ahead and square root both sides. X equals, now be careful, whenever you square root both sides of an equation, you need to have a plus or minus in front. And then the square root of -1 is I. So we have 3 solutions to this. We're going to use curly braces to denote the set of all 3 solutions. So x equals 0, I, or -I. Are 3 solutions, which makes sense because it's a cubic, so we can have at most 3 solutions. All right, let's go ahead and move on to number 3. We have x to the 4th minus 64 is equal to 0. Well, I'm noticing this is a binomial, and I think we can do difference of squares here. So we can rewrite x to the 4th as x squared squared. Minus 64 we can rewrite as 8 squared equals 0. From here, this factors to x squared minus 8 times x squared plus 8, which equals 0. From there, we can set each factor equal to 0 and solve. So x squared minus 8 is equal to 0, or x squared plus 8 is equal to 0. Next step, we're going to go ahead and add 8 to both sides. We're going to use the square root method here. We end up with x squared is equal to 8. Next step, we are going to square root both sides. X equals, don't forget the plus or minus. Now let's go ahead and simplify this. 8 does have a factor that is a perfect square. So you can actually think of 8 as the square root of 4 times 2. So x equals plus or minus, square root of 4 is 2. 2 is not a perfect square, so it stays under the square root. So I just simplified root 8 to 2 root 2. Okay, so we have 2 answers for that one, and then we still have to solve this one. So I'm going to subtract 8 from both sides. We end up with x squared is equal to -8. I'm going to go ahead and square root both sides. X equals, don't forget the plus or minus. Now this is square root of -8. We end up with x equals plus or minus. Let's think of this as the square root of -1 times 4 times 2, right? Those all still multiply to -8. And then x equals plus or minus square root of -1 is I, and then square root of 4 is 2 root 2. So for this fourth degree, note we have 4 different answers. X could be positive 2 root 2, x could be negative 2 root 2, x could be I 2 root 2, and x could also be negative I 2 root 2. Now notice we got 4 distinct solutions. It was a fourth degree. Be careful here because on problems like this, a lot of students like to just say, oh, I can add 64 to both sides, then take the fourth root. Well, it turns out that the fourth root of 64 actually has 4 solutions that you won't get if you just solve it in that way. So you have to make sure that you recognize it's a difference of squares and factor it first, and then set your factors equal to 0. Otherwise, you'll miss out on getting those imaginary solutions. Okay, let's go ahead and jump into the next page. Let's go ahead and do number 5. So number 5, it's not exactly in the form that we want it in. It's x to the 4th plus 3 equals 13 minus 9x to the 4th. So your first step is always to move everything to one side so that it's set equal to 0. So I'm going to add 9x to the 4th to both sides. I'm also going to subtract 13. All right, so here we end up with 10x to the 4th. 3 minus 13 is minus 10, which equals 0. Remember, always look for a GCF, and in this case, we have one. So I'm going to factor out a 10, and I'm left with x to the 4th minus 1, which equals 0. Now we're not quite ready to set x to the 4th minus 1 equal to 0 yet. What we need to do first is factor it and recognize that this is, in fact, a difference of squares, because we can rewrite x to the 4th as x squared squared minus we have 1 squared, which equals 0. From there, we can go ahead and factor using just our difference of squares rule. We have x squared minus 1 times x squared plus 1 equals 0. And then from here, we can just set each factor equal to 0 and solve. So x squared minus 1 equals 0, or x squared plus 1 equals 0. All right, so next step, I'm going to go ahead and add 1 to both sides. We end up with x squared equals positive 1. Square root both sides. Do not forget the plus or minus, so x equals plus or minus 1. Here I'm going to subtract 1 from both sides. We get x squared equals negative 1. Square root both sides. X equals plus or minus square root of negative 1 is I. So for this fourth degree, once again, we end up with 4 solutions. X equals 1, negative 1, I, or negative I. All right, let's go ahead and jump into number 7. So number 7, once again, it's a problem where we do not have it set equal to 0 yet, so we have to subtract 16 from both sides first. We end up with 3x to the 4th minus 2x squared minus 16 is equal to 0. Okay, from there, we have a trinomial. And this one's kind of like what we did in the last lesson. I would recommend, in order to solve this, let's let x squared equal a, and we're going to kind of make this look like a quadratic, so it's a little easier to factor. So this would be 3x squared squared minus 2x squared in parentheses minus 16. I'm not going to put the equal sign in here yet. I'll add it back later. I just want to finish factoring this thing first before I set anything equal to 0. Well, anywhere I see an x squared, I'm going to replace it with an a. So I have 3a squared minus 2a minus 16. Well, because there's no GCF, what I'm going to have to do next is slip and slide. So I'm going to steal the 3, and I'm going to give it to the 16. So I have a squared minus 2a We have 16 times 3, which is going to be minus 48. Okay, from there, I'm going to look for two numbers that multiply to negative 48 and add to negative 2. Well, I'm thinking 6 and 8 are going to work, but we need 8 to be negative in order for them to add to negative 2. So this will factor to a minus 8 times a plus 6. All right, from there, we stole the 3, so now we need to take it back. We're going to divide both of these constants by 3. Remember, you slide if you can't reduce and there's still something in the denominator. So we have 3a minus 8 times a plus 2. Now here's where you have to be careful. We're going to sub back in x squared for a. So we have 3x squared minus 8 times x squared plus 2. And now I can bring back that equals 0 because I'm ready to solve. All right, so from there, we can basically just make sure that we set each of our factors equal to 0. I'm running out of room a little bit, so I'm going to move this up here. We have 3x squared minus 8 equals 0, or x squared plus 2 is equal to 0. Okay, from there, it looks like square root method can be used again. So we're going to add 8 to both sides. We get 3x squared is equal to 8. Divide both sides by 3, and x squared equals 8/3. From there, we're going to square root both sides. We get x equals plus or minus, don't forget about that when you square root both sides. Now, let's go ahead and clean this up just a little bit. You can take the square root of each, the numerator and the denominator. And then we can rationalize this, but also I'm noticing that root 8 does have a factor that's a perfect square. It would be 4 times 2. So we can actually rewrite this as plus or minus 2 root 2 over root 3. I'm going to multiply by root 3 over root 3 to get x equals plus or minus 2 root 3 times 2 is 6 over 3 would be our first answer. Okay, then I'm going to solve x squared plus 2. Subtract 2 from both sides. X squared equals negative 2. From there, we square root both sides. And x equals plus or minus, and then we can rewrite this as I root 2. Okay, so we have 4 solutions. We have positive 2 root 6 over 3, negative 2 root 6 over 3, I root 2, and negative I root 2. All right, we have one more left. We're going to go ahead and do number 9 together. So number 9, we have 4 terms. So thinking about the factoring methods that we use for 4 terms, as of right now, the only one we really have is grouping. So we're going to go ahead and group the first 2 terms together and the last 2 terms. Note, it's already equal to 0, so we don't have to really worry about that first step. Okay, then I look at the GCF for each of my groups. So between x squared plus 2x, x cubed plus 2x squared, we're going to pull out an x squared. I'm left then with x plus 2 in the parentheses, plus 5x and 10, I'm going to go ahead and pull out a 5. We have x plus 2 again left in the parentheses, all equals 0. Then we can pull out an x squared plus 5. And it's times x plus 2 equals 0. So the reason we can do this is because x squared and 5 have a common factor of x plus 2, so technically we're pulling that out. Okay, from here, I can set each of my factors equal to 0. So x squared plus 5 equals 0, or x plus 2 equals 0. From here, I'm going to subtract 5 from both sides. We get x squared equals negative 5, square root both sides, and x equals, don't forget the plus or minus, I root 5. And then next, just subtract 2, and we get our next answer of x equals negative 2. So notice we just solved a cubic and we ended up with 3 solutions. So we have I root 5, negative I root 5, and negative 2. All right, so at this point, I would like you to go back and work through all the even problems. I have posted the solutions to Google Classroom so that you can check your work. All right, thank you and have a great rest of your day.